Okay, so back to this. So is everyone happy with their look and feel? Everyone got their styles together, got images, and understands how 9-patch works or what it does and so on. Yeah, we did a little bit of error handling. If things fail, we pop up a little toast. So for example, if I say hello and now press update, it's gonna say updated successfully. But if I press update again, it's going to fail. Okay. So another thing that I want to show you that's a little bit on a technical side. Yeah.
I was looking at the slides and the book also, like none of that really talks about the style sheet kind of concept. Are you going to add it or add that?
Yeah, I haven't covered it. I haven't covered it in the book. Yeah. Okay. I know. Yeah. Yeah. Thanks for pointing that out. I have it as a to-do. So one day I'll get back to it. Okay. So one thing that I wanted to point out is that I can crash this application. So let me show you this. If I click on update and I click on update again, let me see if I can if I can get it to crash. Yeah, I'm trying to crash it really hard. Not that kind of crash. I'm trying to get. So let me quickly disconnect from the network. And if I do it now, this is what I wanted to bring up. Okay.
The catch didn't catch this?
The
catch statement didn't catch it?
It's not the problem with the catch statement. The catch statement would have caught it.
Right.
So let's look at the code and explain why that is. So the catch statement is fine. Nothing wrong with the catch statement. But I don't need this open. So let's look at the code. So we press the on-click button, right? And we now connect to Twitter and try to update the status, right? But how long is this taking? Especially if I don't have the network enabled. It's gonna sit there and keep trying because it doesn't know, hey, is the network down? Is there network latency? There's just too much data. Network is slow. Connection is slow. It could be a zillion things that are going on. And so basically this is sitting there waiting. Okay? In the meantime, in other words, it's blocked. In the meantime, I'm trying to click on the button to do something else, and it's not responding. And so what happens is the application says, whoa, we're not responding. Would you like me to kill this application or not?
So the application manager is doing that?
Yes. So the application manager brings this and says, look, this app ain't responding. What do you want me to do? Do you want me to kill it or do you want to wait for it? And if we wait for it, it's actually eventually going to come back and everything's going to be good, right? We're just basically saying, okay, fine, give it more time. It's not responsive, but give it more time. Versus saying, no, just force close it. But it's a bad app, right? You guys just wrote a bad app. Did you know that? Okay.
Even if I had a finally there, you're saying it doesn't even go there.
It doesn't even. It does. The problem is that it's blocked. So it's not that it's failing, or it's not that we need something in finally. We could do something in finally. But the problem is that it's sitting here, trying really hard to update the network, and it's just sitting there.
Twitter doesn't have a timeout?
Hmm?
So the Twitter API doesn't have a timeout? It won't come back with like a socket exception or something?
It would. It would come back with a socket exception in like, what, 30 seconds?
Yeah.
That's what happens. See, if I said wait, it came back, nothing failed, right? Nothing happened. But the problem is I had to wait 30 seconds. That's not a very responsive app. As a matter of fact, if your app doesn't respond within 3 seconds, the system brings up that thing. Okay. So what I want to do is I want to show you a couple of things. See, eventually came back and says failed, right? So what I want to do is I want to do a couple of things. I want to measure the execution of this first to show you what's going on, what's wrong with it, and then I want to fix it. Okay. So to measure the execution of this, we're going to use a tool called Traceview. But before we can use that tool, we're going to need to generate a trace file. Before we can generate a trace file, I need to explain to you what the file system looks like. Okay. So I'm going to jump to a quick section here on a file system, just to talk really briefly about that. And when I say file system, I'm referring to the file system of the actual. The projector is off again a little bit. File system of the actual device, right? So this is what the device file system looks like. It's got 3 partitions we care about: data, SD card, and system. Okay, those are sort of 3 things that we care about. So what we're going to do is we're going to look at these partitions. But as opposed to showing you on a dumb static slide, I'm going to switch over to DDMS and actually poke around the live file system of one of my emulators. It doesn't really matter which one. Let's see if something changed in 2.3. They added more stuff. But so these are the 3 partitions. So I'm going to start with just talking about the system partition. So the system partition is where all the system-related stuff is. System partition corresponds to what image? Does anybody know? System.img, yeah. Remember, we talked about that. I said if you're a platform developer, this is what you ship at the end of the day. This is what you need to produce, and then it gets flashed onto the device, and that's a new phone, right there. Okay. So system image. So system image contains a bunch of stuff, such as default apps, right? These should look familiar: calculator, camera, contacts, desk clock, email, browser, and so on and so on. So these are the default apps that ship with the phone, right? What do you notice about this? I said system partition is mounted read-only. So that means what about these apps? Yeah, you can't get rid of them. But wait, didn't I say yesterday you can replace apps? Just like on Windows, you can replace your Internet Explorer with a Firefox.
You could install others and then add the other intent to it and
Yeah,
select which one.
exactly. So in other words, you can't get rid of these ever as a user, but you can successfully ignore them. Just like Internet Explorer, you can never really get rid of it. Anybody tried? I mean, it's so entrenched in the system, right? But you can successfully ignore it. So that's sort of similar comparison, right? Still. Okay, so apps is where it won't close. Okay, apps is where apps are, applications, right? Bin is where you have some binaries, like such as your standard Linux command line stuff, like cd, chmod, ls, that sort of stuff. Okay, etc is your etc directory. Framework is where you have your app frameworks. Okay, some Java classes. Lib is the only place that is in the LD library path. And what lib is basically the libraries. It's your C libraries. It's your shared objects, .sos, right? That's where like your libssl, libso, lib, OpenGL, lib, OpenCore, and so on. They're all in here, okay, in lib folder. And then you have some other stuff. Okay, so let me just kind of show you this differently. I'm gonna kill this. I'm gonna open this in images. images, there's a image Android stack. Okay. Oh, I can do it. I can do it like this. Let me. Well, I can do it like this. So, roughly, only roughly speaking, the apps. Okay, apps go into this folder here. App folder. Okay. Except user apps, you're gonna see later on, go into this folder here. Okay, that's your applications. App framework, should use a different color. App framework goes into frameworks folder. Okay. Libraries go into libraries folder. Okay. And then this stuff at the bottom goes all over the place, but let's say it goes into bin folder. Something like that. Got it? So yes, so yeah, let's take a look at that now. So that was the system partition. So system partition, as I said, is important for platform developers, but for us, we don't really have a lot of business there, right? So we can't influence anything, so no big deal. Okay. Now, please close yourself. So let's look at the data partition. So data partition corresponds to what image? Yeah, user data.img, yeah. And so that's where user-defined apps are. So this is the one that we installed. App private, I'm not quite sure what it is. There's a mechanism of moving apps back and forth to SD card. So that could be part of that, but I'm not sure. Okay. So that's apps, right? Other than that, as an app developer, the most important place for you on the entire file system is a place called /data, and then /your package. So every single app, regardless if it's a system app or user app, has a private piece of file system here. Okay, so ours is somewhere here, and there it is. And there isn't much in there right now, but we do have our own part of the file system. And by the way, it's because we have root privileges on the emulator that we can even see this. So if you connected my phone, wherever it is, you can't see these folders, right? It just wouldn't allow you.
How about the shared data? Also go to that directory, something like a database?
Shared data.
Something like a database, and application need to share the data.
Yes, but that's all within the application, right? So if you're sharing the data, you're sharing the data within the application, so it's going to go into the app private folder. It goes into, there's a folder underneath this. We'll see that folder when it gets created. Okay, so that is the that's basically the file system at large, the /data partition. Now there's one more partition, and that's the SD card. And what SD card pretty much is sort of a free-for-all storage. You get to store stuff there. Okay, make sense? Okay, so now here's what I want to do. I want to turn on tracing so that we can trace what the heck is going on our device. So I'm going to go to our status activity, and I want to, you can, when it comes to tracing, you need to basically trace between point A and point B. You need to start somewhere, you need to stop somewhere. And you can choose whatever these 2 points are. It doesn't really matter. But just for the sake of argument, what if I wanted to start tracing as early as possible? So what's the first place where I can start tracing? On create, okay. And what line in on create?
After you're done with the set content.
You can actually do it before set content view, but after super on create, because you got to call the super first. So the earliest I can do anything is here. So I can do something called debug dot start method tracing, and you can give it a trace name, file name if you want. I'll call it yamba.trace. Okay. So this turns on tracing. Okay, so now I want to stop tracing. What would be a good place to do a stop? You know, you guys have a good point. I mean, the opposite of on create would be on destroy. However, the problem is that I don't have a control over on destroy. Right? I can't really have it run. But what I could do is I could stop my activity. Right? So instead of doing on destroy, I'm gonna do in on stop. Okay? Just because it's easy to stop an activity, you just leave the screen, right? You hit home button or something. So I could now, you know, go here and I could write, override, blah blah blah. But if you don't like typing, you can also use the shortcut source, override, implement methods, and Eclipse knows which, you know, where your location is. See, it knows that I'm an activity, so it gives me all the options that I can override, implement based on my, you know, being an activity. So I'm gonna do on stop, bam, and that adds the method there. So it just saves you typing. So you go source, override, implement methods. So the opposite of debug start is debug.stop method tracing.
There is something called on destroy also with this.
Yes, so there is on destroy. It's just that we don't know when on destroy is going to happen.
But that is not under our control.
Yeah, because it gets called at some point by somebody. Yeah. Yeah. So that's the problem with on destroy.
So is that like the name that you gave inside the start identifier or just a string? Debug the start method.
This is just a name.
Oh. So
Yeah.
it's not that start and the stop are matched up.
Yeah. Yeah, so this is our point. So this is our point A. So point A is here, and this is our point B. Right? So we start and we stop. Everyone good so far? Okay, so I'm gonna run this. And this is going to, it's going to crash miserably. Yeah. Why did it crash? No, it's not. I still have disabled network, but that's not the reason. Remember, this means read the logcat, right? So you would basically open up your terminal, adb dash. You know what? Let me kill the other emulator, so I don't have to deal with you know, serial numbers. So adb logcat, bam, and you fast forward back to the top of the exception, and there it is. And what does it say?
There's a preference thing, like you need to add permissions.
Yeah, so you just got this answer right away without using your brain too much. You now go to where do we define all the preferences? It's in a manifest file, and it's going to be just yet another user's permission, right? It just this time around it's going to be a user's permission, write external storage. So I'm going to do it like this manually. Uses permission and see, this doesn't work. Android name equals Android dot permission dot write external storage. You could have also found it in the list of permissions, but the key again is to say uses permission. How do you find that? It's a good question. If you are not on Linux, you can go here and you can do it under this, under permission tab. Yeah, select it and then you can find it in there, right? So I could have gone here and say, look, there's the right external storage. Bam, save it. So that would be one way. Sometimes when it dies, it tells you what's missing. It actually says, do you have camera permission? Do you have location permission? So that's very useful. So it's faster to actually let it crash and read the logcat than to actually figure it out. If all that fails, you read the documentation. I guess we should be reading the documentation first, but it's not how we're wired. So that's why we have the RTMF term, right, in the first place. Okay. Sure. So we're gonna now run it again. Okay, so presumably now it's tracing. I can check that by going into DDMS perspective. See how sometimes you go to DDMS and stuff, you're like, there's nothing, right? You guys notice that, right? Or logcat, you're like, there's nothing in my logcat, right? That's because it doesn't know that you haven't selected the emulator. It doesn't have the active, whatever device, right? But anyway, let me show you. So now if I go to the SD card, notice that there's a Yamba trace file, but also notice that its size is 0. Right? So we do have a trace file, but there's nothing in it. That's because point B hasn't happened. So I can now go, let me actually have this work, right? So I'm going to turn on my my thing again. I'll say hello with Traceview. Okay. Click on update. Okay. It failed. Try again. Failed. Okay.
Yeah, mine too.
Wait or force close?
Yeah.
That's
No wait also, it's just the application stopped and it's
oh, okay. If there's no wait, then it crashed. It's different than in this case. The reason is that value HTML head meta of type string cannot be converted to JSON object. Whatever we're getting as a response is not a good response. Oh, you know what's going on? Here. Let's go back to /dot. Sorry, I just have to read a little bit of news first. Now, if I click on update, it's gonna work. Woohoo! That's because your firewall was preventing my connection. When I wasn't getting a response. I was like, wait, this meta response makes no sense. That's probably because this was the response from your firewall saying log in first.
Oh, yes,
Yeah. So anyway, what I want to do now is my file is still 0. So how, that's because point B hasn't happened. How do I have point B happen? I can hit the back button, I can hit the home button, just any way to leave the screen. And notice that now, it takes time, but notice that now that we have a file. Woohoo! Pretty big, it's like half a gig, half a meg. The answer is in the logcat. What does it say? Remember, the crash message says read the logcat. Did you figure it out? Okay, so what we should do, so now this is finished. Where we have the file. So how do we look at this file? So far I've been showing you this stuff through the WYSIWYG tool, right? So look, one way I can grab this file once you have it is I could use the pull and push to get this file. So it's sort of like FTP, right? So I can click on this and I can now say, okay, grab that yamba.trace and dump it on my desktop. And there it is. Copy the file over. So it moves file from one computer to another. So it's these two buttons, push and pull. Okay. Now, like I said before, there's no real magic to this stuff here. It's really just stuff that sits on top of ADB. Alternatively, I could have done ADB shell and gotten onto command line. That's answering your question. So I could have gone CD as the card and done L as the shell, and there's my file as well, right? Yamba trace. Right? If I yes, there is a cat inside of shell. The cat is one of the things that there is. There's cat, there's dog, there's mouse. If I wanted to copy the file manually, I'm going to exit the shell. I'm going to CD into my desktop. Right? If I wanted to copy a file manually, I can again use ADB and push pull. So pull from SD card yamba.trace to current working directory. Right? This is the command line version of copying the file over. There, open it. And now I can examine this file on my desktop with much more tools. I can say mate yamba, and bam, it opens it up in my my editor. There it is. And you can see it's just a text file, more or less. There's some binary stuff later on. Okay. So to pull it, I did ADB pull, then the name on the device, so the remote name and then the local name. Right?
But if you have a phone, is that the same command or different command?
The which one?
If you connect the phone,
Same command.
so you know which device is going to pull? Or?
Well, no, I mean, just like before, you would, if you have competing devices, you would have to do ADB-D or -E or -S and then serial number. Yes. But that's true for any ADB subcommand, right? So you gotta say ADB and then to what device if you have more than one. Yeah.
Actually, when it was on the file explorer, if I go under MMT, doesn't seem to have any file now.
Let me take a look. So in the status activity.java, all we did is we added the point A and the point B. You could have just said start method tracing without this, right? It would have come up with a file name. But basically the point was to start here. So that was point A, start, and this is point B, stop. And everything that happens between these 2 points is recorded in that file.
So that thing could grow enormously.
Yep.
So if you leave it on, basically, the pressure system.
Well, at some point possibly, yeah. But it's only tracing while there's some execution. So yes, if you leave it on and it's running something, yes.
So that push pull from Eclipse, when it pushes, it will actually give you a confirmation of the push.
You push into Eclipse? I think so. I think so. Okay. So now that you have that trace file, and we copied it onto our desktop, right? So it's right here. If I do ls-shell yamba, it's right there, right? The trace file. Now what I can do is I can use a tool called Traceview that's in a toolbox. It's in your tool set, in your SDK tools, right? And I can analyze this file. So Traceview space yamba.trace. Okay. Let me just generate a different file because this I'm not happy with this particular. I was talking too much while I was doing this. So what I'm gonna do is I'm gonna run the app again. Okay. So I'm gonna do another experiment, right? So I'm running the app. Hello with Traceview. Okay. I'm gonna click on update. It's updated successfully. I'm gonna press home. Okay. And I'm gonna copy that trace file again. Okay, and now I'm gonna view it again. So see.
It overwrote the original file.
Yes.
What is it? Every invocation is one new file. Or?
Exactly. Yeah, giving pretty much the same.
Traceview is on the tool somewhere? Where is Traceview?
Traceview is the same place where ADB is, where draw9 patch is, where all those tools are. SDK/tools. So in your SDK directory /tools. Remember that directory that we should have put in the path so that we don't have to worry about it? You know what I'm talking about? If you're on the VM, you have it in the path. So what this tells me is basically the execution of stuff, right? Right. So I can zoom in like this. I can zoom in on a particular area, right? And for example, this is where we're reading the socket. So this is the networking piece, right? See, I can zoom out. Now, your guys' network is unfortunately fast. So let me try to do it with a slower network. So what I'm going to do is another experiment. I'm going to shut down my airport, okay, a wireless. I'm going to rerun the application, okay. Actually, you know what? I'm going to just make sure that actually it does rerun. So I'm going to change the code to reinstall the new code, okay. So just to be sure, my application is starting. Okay, so hello from Traceview. Okay, click on update. I touch here. Notice that I'm probably gonna get that force closer wait. Okay, I'm gonna click on wait. Okay, and I'm gonna wait for it to finish, which may have to be 30 seconds since my network doesn't exist, so it may need to time out. Okay. Okay, it finally failed. Now I'm gonna leave the page. Okay, and hopefully I have a new file. So I'm gonna pull that file again. Okay, and I'm gonna open it. Okay. So this is my trace file, right? So it took 16 seconds, the entire execution, right? 16 seconds approximately. What I want you to notice is that there's basically one main thread. Everything worked on this main thread. This thread is also known as a UI thread, user interface, because that's by default your app has one and only one thread, and everything runs on it, right? So so that's where the things are running, and if we have something that's long running on it, taking a long time to run, then that thread is not going to be very responsive because it's going to be waiting for that something. And I kind of suspect that there's some kind of issue here because you see something that's very same color for a long time, right? So what I would do is I would double click on that area. So I'm going to zoom in. And if I click on it, you can see that all those are actually it seems like they're network calls. They're all I/O input stream. So that's probably where we are basically getting the data, attempting to read the data. Okay.
So the yellow highlighted below is the area that you selected above?
Exactly. And that tells you that what I'm looking at took 18% or 3,000 milliseconds, 3 seconds, that it was one call and 0 recursive calls and so on and so on. So it tells you how long it took and what. So you can use the Traceview to find bottlenecks in your code. Okay.
When trying to run Traceview, it kicks back saying that it's a way out of bound exception.
Okay, let me take a look. Does everyone understand then what the problem is? So the problem is basically that while we are attempting to do the network call, everything else is blocking because we are doing it on a UI thread. That was my goal. That was my point here, right? So we have one thread only doing all the work. And while it's busy with networking, everything else has to wait. And that's why the system pops up that force close or wait window, right? Because the application is very non-responsive. So we're going to have to address that. Any questions on that? Okay.